Okay, so here is our galvanometer, and it is a compass, and we've got a 22 gauge wire that is wrapped around the compass. So I've got a piece of cardboard cut, and I simply place the compass on the cardboard, and then I've got a number of wraps, just simply wrapping the wire. I started with about 6 or 8 inches of wire, excess wire, and then started wrapping the wire around the compass. And the activity in the book actually shows using a brass tack. But basically what you want is something to keep the wire from wanting to move the compass, the entire compass body, that is. So I'll just simply cut some slots in the cardboard, and now I've got a place to attach the wire to allow me to have these leads, so to speak, to hook up the rest of the circuit to. So your circuit in activity 5, here's our galvanometer, and I also had to strip the insulation off the end so you can make the connections. You need your switch. There's a cardboard switch, and you're going to need a power source. In this case, a 1 D cell battery of 1.5 volts. And now I'm going to use my alligator clips again. Once again, you can do this real quick. So there is the black alligator clip going to the black lead on my battery. On the negative side, I'm going to attach a red alligator clip to the positive lead, or red lead. Then I've got alligator clipped to one lead on the galvanometer. And the other thing I'm going to do is I'm going to orient the compass so that the needle, and you'll notice there's a little bit of space in between the wire wraps, so I can still see the needle, but I'm orienting the needle, I'm pointing the compass north so that it lines up. What I want to do is line up the needle with the wire, so now they're parallel. And just to go the opposite direction, just to illustrate that again, you can see as I rotate the compass so that it's facing north, now that needle is pointing that way. It's lining up with magnetic north. Okay, we need one more alligator clip. I may have to reorient this a time or two. And so I added another alligator clip now that I have a wire going to from the opposite lead on the galvanometer to the other lead on my switch. And I think I've got everything oriented. So when I close the switch, you should see that the compass needle moved, and so it's essentially rotated 90 degrees. So what it's doing, because of the presence of the magnetic field flowing as a result of current flowing through the conductor, in this case the wire wrapped around the compass, it's now perpendicular to those wires. That was another reason for lining it up. So now I've opened back my circuit, and we'll close it again, and you should see the needle move. And what you can do is also is if you'll notice the direction it's rotating, see the rotating counterclockwise or clockwise. And if we were to change the polarity of the battery, we switch to the red lead and the black lead, you would see it spin in the opposite direction.